Imagine for a second that everything you've been told about the future of cars was just a distraction while a much bigger storm was brewing in the East. Right now, in 2026, the automotive world is witnessing a shift so violent that it's being called the extinction event for legacy car brands. While Western engineers were obsessed with making luxury electric toys for the elite, China was quietly perfecting a weapon that targets the very heart of the global economy. This isn't just about another electric car with a slightly better screen or a faster charging port. We are talking about a revolutionary propulsion system that combines the brutal efficiency of advanced electric motors with a thermal energy core so advanced it makes modern gasoline engines look like steam engines from the 19th century. This technology has officially hit the streets of Beijing and Shanghai, and it's not a concept or a dream anymore. It is a reality that is causing actual panic in the boardrooms of Detroit and Stuttgart. The question isn't whether EVs will win or lose, but rather who will survive the arrival of this new Chinese powerhouse. In the next few minutes, we are going to peel back the layers of this mystery to understand why companies like Tesla and BYD are suddenly in a race where the rules have been rewritten overnight. You need to watch this until the very end, because what we are about to reveal about the internal mechanics and the secret strategy behind this engine will explain why your next car might not come from the brands you've trusted for decades. The true story of this revolution didn't start in a high-tech lab last year, but began with a calculated gamble taken nearly 25 years ago, when the rest of the world was still obsessed with massive V8 engines and cheap oil. Back then, China's megacities were drowning in a sea of toxic smog, and the government realized that relying on foreign energy imports was a strategic trap that could collapse their economy at any moment. They didn't just decide to build cars, they decided to invent an entirely new ecosystem that would force the rest of the world to play by their rules. This started with the legendary 863 program, which poured billions into clean tech long before the word sustainability became a marketing buzzword. They focused on the boring stuff first, like electric buses and public utility vehicles in cities like Shenzhen, until they had perfected the infrastructure for mass electrification. By the time Western companies realized that EVs were the future, China already owned the mines, the refineries, and the battery patents required to build them. This wasn't just a technological advancement, it was a geopolitical checkmate. When the dual credit system was implemented, it gave local manufacturers a choice to either innovate at lightning speed or vanish from the market entirely. The result was a surge of local brands that stopped imitating the West and started out-engineering them. Today, the real magic happens inside the motor and the control systems, where China has achieved a level of vertical integration that seems almost impossible. While a traditional car company has to deal with thousands of different suppliers for their parts, a giant like BYD or Xiaomi now builds almost everything under one roof, from the semiconductors to the safety sensors. This is exactly how they've managed to launch engines like the DMI 5.0 system, which delivers a thermal efficiency of over 46%. To put that in perspective, that is a number that engineers once thought was physically impossible for a mass-produced engine. This leap allows a car to travel over 2,000 kilometers on a single tank and a charge, which effectively kills range anxiety forever. It's not just about the distance either, because these new permanent magnet motors deliver a level of instant torque that makes a sports car feel sluggish. When you press the pedal in these new 2026 models, the response is measured in milliseconds, because the energy flow is managed by AI-driven inverters that calibrate power delivery faster than a human brain can blink. But the most terrifying part for the rest of the global market is the cost. By moving away from expensive and controversial materials like cobalt and focusing on advanced lithium iron phosphate technology, China has managed to slash the price of power. They are producing motors that are smaller, lighter, and more powerful than any internal combustion engine, while keeping the price tag low enough for the average consumer. This is why the BYD Seal and the new Seagull models are not just competing, they are dominating. They offer a driving experience that feels like the future, but at a price point that feels like a bargain from the past. This combination of raw performance and extreme affordability is the secret sauce that has allowed Chinese brands to leapfrog over a century of Western automotive history. They didn't just find a better way to build a car, they found a way to make the traditional car obsolete. As these vehicles begin to flood the markets of Europe, Latin America, and Southeast Asia, the global industry is realizing that the Great Wall isn't just a monument anymore, it's a technological barrier that no one else seems able to climb. As the world stands in awe of China's silent engines and record-breaking range, there is a much deeper and more controversial story unfolding beneath the surface that rarely makes it into the glossy marketing brochures. While we celebrate the end of tailpipe emissions, we often forget that the energy powering this revolution has to be stored somewhere, and that somewhere is a complex chemical cocktail known as the lithium-ion battery. China didn't just become the world's battery factory by accident. They understood early on that the true crown of the automotive kingdom wasn't the car itself but the power cell hidden in its chassis. This realization sparked a global treasure hunt for raw materials that has reached the furthest corners of the earth, from the high-altitude salt flats of the Andes to the deep jungles of Central Africa. The sheer scale of China's dominance in this sector is staggering because they don't just manufacture the batteries, they control the entire supply chain from the moment a mineral is pulled from the ground to the second it is installed in a vehicle. Companies like CATL and BYD have become the gatekeepers of the global green transition, and their influence is so vast that even the most powerful Western governments are finding it nearly impossible to decouple their economies from Chinese battery tech. However, this massive industrial machine comes with a hidden environmental and human price tag that is starting to trigger a global debate about the true cost of going green. The extraction of lithium, which is often called white gold, requires an astronomical amount of water in regions that are already struggling with extreme drought and desertification. In some parts of South America and Western China, millions of liters of water are evaporated just to produce a single ton of lithium, leaving local farmers and indigenous communities with dry wells and dying livestock. This creates a bitter irony where the quest to save the planet from carbon emissions is simultaneously destroying local ecosystems and depleting life-sustaining resources. But the problem goes even deeper when we look at cobalt, which is a critical component for high-performance batteries. A massive percentage of the world's cobalt supply flows through Chinese-owned mines in the Democratic Republic of the Congo, where reports of hazardous working conditions and child labor have haunted the industry for years, even though Chinese manufacturers are now racing to develop cobalt-free. Kingdom wasn't the car itself but the power cell hidden in its chassis. This realization sparked a global treasure hunt for raw materials that has reached the furthest corners of the earth, from the high-altitude salt flats of the Andes to the deep jungles of Central Africa. The sheer scale of China's dominance in this sector is staggering because they don't just manufacture the batteries, they control the entire supply chain from the moment a mineral is pulled from the ground to the second it is installed in a vehicle. Companies like CATL and BYD have become the gatekeepers of the global green transition, and their influence is so vast that even the most powerful Western governments are finding it nearly impossible to decouple their economies from Chinese battery tech. However, this massive industrial machine comes with a hidden environmental and human price tag that is starting to trigger a global debate about the true cost of going green. The extraction of lithium, which is often called white gold, requires an astronomical amount of water in regions that are already struggling with extreme drought and desertification. In some parts of South America and Western China, millions of liters of water are evaporated just to produce a single ton of lithium, leaving local farmers and indigenous communities with dry wells and dying livestock. This creates a bitter irony where the quest to save the planet from carbon emissions is simultaneously destroying local ecosystems and depleting life-sustaining resources. But the problem goes even deeper when we look at cobalt, which is a critical component for high-performance batteries. A massive percentage of the world's cobalt supply flows through Chinese-owned mines in the Democratic Republic of the Congo, where reports of hazardous working conditions and child labor have haunted the industry for years, even though Chinese manufacturers are now racing to develop cobalt-free batteries like the lithium iron phosphate or LFP cells. The legacy of this resource war continues to cast a long shadow over the clean energy narrative. The industry is no longer just fighting a technical battle, it is fighting a moral one as consumers begin to demand more transparency about where their car's heartbeat actually comes from. To counter these growing concerns and maintain their lead, China is now pioneering a closed-loop system that the rest of the world is desperately trying to replicate. They have invested billions into massive battery recycling plants that can tear down old EV cells and extract up to 95% of the valuable minerals to be used again in new production lines. This strategy isn't just about being environmentally friendly, it is a brilliant economic move to reduce their dependence on mining and insulate their companies from the volatile prices of global raw materials. Furthermore, they are breathing new life into degraded batteries through second-life applications where cells that are no longer strong enough for a car are repurposed to store solar and wind energy for the national grid. This turns every car battery into a long-term asset that continues to serve the energy system for decades. Yet, as the demand for electric vehicles continues to explode across Europe and Asia, the pressure on the planet remains immense, because recycling alone cannot keep up with the millions of new cars hitting the road every year. Every new milestone in range and power requires more earth to be moved and more chemicals to be processed, which keeps the global industry in a constant state of tension between technological progress and ecological preservation. This brings us to the next phase of the global power struggle, where China is preparing to move beyond the liquid battery altogether. While Western competitors are still trying to catch up with current technology, Chinese researchers are already testing solid-state prototypes that promise to be safer, more energy-dense, and far less reliant on controversial minerals. By moving towards solid electrolytes, they are aiming to eliminate the risk of battery fires and drastically reduce charging times to just a few minutes, which would effectively remove the last remaining barriers to total EV adoption. This relentless pace of innovation ensures that China remains several steps ahead of any international sanctions or trade barriers that the West might try to impose. They are not just selling cars, they are selling the entire future of energy storage, and as long as they control the materials and the chemistry, they control the destiny of every car brand on the planet. The transition to a green future is proving to be far more complex than just swapping an engine for a motor. It is a high-stakes game of resource management and industrial endurance, where the winner gets to decide how the world moves for the next century. The world is currently witnessing a tectonic shift in the global hierarchy of the automotive industry as Chinese brands move from being domestic players to becoming the new masters of international trade. For decades, the car industry was defined by an untouchable elite of German precision, American muscle, and Japanese reliability. But in 2026, that old world order has been shattered by a tidal wave of high-tech vehicles from the East. This global expansion isn't just about selling more units, it is a sophisticated strategic takeover that uses a combination of aggressive pricing and technological superiority to make traditional brands look like relics of a bygone era. When a customer in London, Paris, or Bangkok walks into a showroom today, they are no longer just looking at a cheaper alternative, they are seeing cars that offer more range, more intelligent software, and more luxurious features than European models that cost twice as much. This value proposition is the Trojan horse that has allowed companies like BYD, MG, and NIO to capture massive market shares in territories where Western brands once held a monopoly for over a century. By controlling the battery costs and the manufacturing supply chain, Chinese companies have reached a level of pricing power that their competitors simply cannot match without going bankrupt. In Europe, which was once considered the fortress of the traditional internal combustion engine, the arrival of Chinese EVs has been nothing short of a revolution. In countries like Norway, where the transition to electric mobility is almost complete, Chinese brands have already established a dominant presence by proving that they can handle extreme climates and demanding consumers just as well as any local brand. But it's not just the northern markets that are falling, because the same story is unfolding in Germany and France, where the legendary car makers are now struggling to justify their premium prices against the onslaught of smart Chinese sedans and SUVs. This expansion is supported by a brilliant logistical strategy where China isn't just shipping cars on boats, but is building massive gigafactories directly on European and Latin American soil. By setting up local production in places like Hungary, Brazil, and Mexico, Chinese companies are bypassing high import tariffs and positioning themselves as local contributors to the economy, which builds trust with both governments and consumers. This move has effectively neutralized the foreign stigma and transformed these brands into global powerhouses that are indistinguishable from the traditional giants in terms of service and reliability. Another critical factor in this global takeover is the sheer speed of innovation and the rapid life cycle of Chinese vehicle models. While a traditional European or American car company might take 6 or 7 years to fully update a model, Chinese manufacturers are operating on smartphone time, releasing significant hardware and software updates every single year. This keeps the market in a constant state of excitement and forces competitors into a defensive position where they are always reacting to China's next move rather than leading the way themselves. In Southeast Asia and Latin America, China has already won the battle for the middle class by providing electric buses and affordable family cars that make the transition away from oil a financial no-brainer for developing economies. In these regions, the Chinese strategy is simple but lethal. Provide the greatest range at the lowest possible price, while wrapping it in a package of modern design and over-the-air software updates that make the car feel like a living, breathing piece of technology. This digital-first approach appeals to a younger generation of drivers who care more about connectivity and AI integration than they do about the history of a brand's badge. However, this global dominance is not just about the hardware, but about the invisible software layer that Chinese companies are using to redefine the driving experience. In 2026, a Chinese car is essentially a high-performance computer on wheels that is constantly learning from its environment and its driver. They have integrated advanced autonomous driving features and cockpit AI assistants that are far more intuitive and responsive than anything currently coming out of the West. This focus on smart mobility has created a new standard for what a car should be, and it is a standard that traditional manufacturers are finding incredibly difficult to meet because they lack the software-first culture that defines the Chinese tech giants. As we see more Chinese flags flying over factories in Europe and more Chinese logos on the streets of the world's most iconic cities, it is becoming clear that the automotive landscape has been permanently altered. The rules of the game have changed, and those who cannot adapt to this new reality of high-speed innovation and vertical integration are being left behind in the dust of the Chinese electric revolution. As we move through the early months of 2026, it has become clear that the automotive world is no longer just anticipating a revolution but is currently living in the middle of one. The final piece of the puzzle that will cement China's total dominance over the global market is the commercialization of solid-state battery technology, which is effectively the holy grail of clean energy storage. For years, the industry has promised a battery that could charge as fast as you fill a tank of gas and offer a range that exceeds 1,000 kilometers, but those were always seen as distant goals. However, in 2026, the game changed because companies like Godion High-Tech and Chang'an have moved beyond the laboratory and are now officially launching pilot production lines that are capable of manufacturing these next-generation cells at a scale the world has never seen. This shift from liquid to solid electrolytes is not just a minor technical upgrade, it is a fundamental transformation that eliminates the risk of battery fires and allows for an energy density so high that a small city car could soon travel from one side of a continent to the other without ever needing a plug. The year 2026 will be remembered as the moment the national standard for solid-state batteries was finally established in China, creating a unified framework that allows manufacturers to move from experimental prototypes to mass-market reality. While Western companies are still debating the economic feasibility of solid-state tech, Chinese giants like CATL and BYD have already integrated these batteries into high-end demonstration fleets that are currently roaming the streets. These vehicles are proving that we can achieve a range of 1,200 kilometers even in extreme sub-zero temperatures where traditional lithium-ion batteries would typically lose half of their power. This breakthrough is being driven by a new generation of sulfide-based electrolytes that are not only safer but are becoming increasingly affordable thanks to massive government-backed research into low-cost raw materials. We are witnessing a transition where the high-performance car of the future is becoming lighter, faster, and more reliable because it no longer has to carry the massive weight of a liquid cooling system. By the end of 2026, we expect to see the first batch of commercial electric coupes equipped with fully solid-state batteries hitting the luxury market with a promise of 10-minute ultra-fast charging that replenishes 80% of the energy. This marks the beginning of the end for the internal combustion engine because the last remaining argument against EVs, which was the time spent at charging stations, has finally been neutralized. China's strategy of combining aggressive industrial scaling with lightning-fast technical innovation has created a lead that is now measured in decades rather than years. They are not just building cars anymore, they are building the energy infrastructure for a world that no longer needs oil. The global auto market is being forced to accept a new reality where the rules are written in Beijing and the technology is perfected in the gigafactories of the East. The race for the future is over, and as we look at the road ahead, it is clear that the next chapter of human mobility will be powered by the silent and unstoppable force of Chinese innovation. If you want to stay ahead of the curve and understand how these technologies are reshaping your world today, make sure to subscribe and hit the notification bell so you never miss a deep dive into the innovations that are defining 2026 and beyond.